So this is my video project. I'm going to be showing you how to do the 2010 AB Form B Problem 4. So this is the problem. The mocap for this problem is be able to use the fun chart along with using the graph of velocity to be able to find the distance traveled, displacement, and acceleration. So part A is asking for what times between 0 and 18 the squirrel changes directions and asks for a reason. This is pretty easy. You can say the squirrel changes directions at time 9 and time 15 because its velocity is changing sign at those points, as you can tell. So that's pretty much the easiest part of the problem. And so for part B, it's asking at what time the squirrel is furthest from building A, and how far it is at that time. So for that, what you're going to have to do is figure out its displacement away from its start. And since you have a velocity graph, you can find the area of the curve to to figure out the distance traveled. And so you just math it out with triangles or squares, as I've done here. So for the first section, it goes away 140 units. For the second section, because it's negative, it's going to be negative displacement. It goes backwards 50. And then for the last section, it goes forward 25. And so we know that it's going to be at its highest point right here at t equals 9, because if you go further than that, you start going into the negatives, and even if you go back up the positive distance of 25, that's less than the negative 50. So you'll still be further away than you were at t equals 9. So the squirrel is farthest from building A at t equals 9, and it's 140 units away, because that's the area under the curve of v of t at that time. This is like taking the integral of v of t, except we don't have a calculator, so we can't actually take the integral, but it's basically the same thing because it gives us a nice geometric graph that we can just math out using triangles. So for part C, they ask you to find the total distance the squirrel travels between time 0 and time 18. So this is actually very easy once you've done problem B, because as you can see, we already have the displacement for the whole time split up into little chunks, and all you have to do is make them all positive and add them together. They're all going to be positive because we're doing distance traveled and not displacement. So we just go over and we add up 140 plus 50 plus 25, and you get 215. So that is your total distance traveled, 215 units. And for the last part, part D, they want you to write expressions for the squirrel's acceleration, velocity, and distance from building A that are valid for the time interval between 7 and 10. So for V of t, it's pretty easy, because you can just look at the graph and you can see that between points 7 and 10, here and here, it's decreasing at a constant rate, because you can see that between t equals 9 right here and t equals 7 and t equals 9, it goes from 20 to 0, and from t equals 9 to t equals 10, it goes down by 10, so it's going down by 10 every time unit. So we can set this up as 90 minus 10t, because we have to start at 20, and so this means that we do have a slope of 10, but since we're starting at 20, you have to set the constant at 90, so that when we're at time t equals 7, you'll have 90 minus 70, so you'll have a velocity of 20, as you have here. And so I've checked this for all the other times, and it works, so that's good. So then, for time x of t, you have to use the derivative of v of t, but you can't just use the derivative from the start to the end. You have to do it from 7 to t, because this way it's easier to work out. So you just do this is effectively the integral from 0 to 7 of v of t, but this way it doesn't get messed up if our model for v of t is wrong, because our model for v of t is only working for time 7 to 10, so it's going to be wrong for time 0 to 7. So, but as you can see, time 0 to 7 totals out to 120 for distance away from the building, So we just add 120, and then we do the integral from 7 to t of v of t dt. And if you want, you can simplify this to 90t minus 10t squared from 7 to x, because we're just using the same v of t equation. So for a of t, acceleration, you don't have to care about anything that happened at the time before right now, because you're just taking it at an instant. It's not the total of distance. So we can just refer to our sort of jank-looking super fun chart for distance and velocity. So you'll see that a of t is equal to v prime of t. So we just plug in v prime of t. If you want, you can simplify that. And it turns out to just actually be negative 10, not just 10, negative 10. Because as you can see, this 90 goes away because it's a constant, and this t goes away when you derive it. So you just get negative 10. And you can see that is the slope that we found earlier, so we know that's also correct. And that's how you do this problem.